Howdy. I stumbled across this one and I thought I'd share this and some of my thoughts about the topic. But anyway, let's have just first read through that in order to just know what they were writing and what they did. EGT geologists learn about geothermal energy exploration methods in Finland. The Geological Survey of Finland GTK, in conjunction with the EGT Twin Project, organized the intense 3D series of short courses on geothermal energy. These courses took place from the 3rd to the 5th May in 2023 in Espoo, Finland. The aim of the course was to cover a wide range of topics from deep geothermal reservoirs to the thermal and petrophysical parameters of crystalline rocks and from rock measurements to evaluating their geothermal potential. The renowned lecturers of the Geothermal Energy short course were Professor Michael Heap from the Strasbourg Institute of Earth and Environment, ITES, France, and Dr. Alexandra Kouchner from the École Polytechnique Fédérale de Lausanne, Switzerland, and Dr. Alain Bischoff from the Geological Survey of Finland, GTK. According to Heikki Bauert and Rasmus Kontov from the Geological Survey of Estonia, who participated in the course on site, it was a great success. About 30 people participated in person, and another 60 attended online, many from Finland and Estonia, but also from other countries. The general objective of these courses was to improve the knowledge on the rock petrophysical characteristics for geothermal energy studies. Especially important was the course for the participants from the Geological Survey of Estonia, as geothermal energy is a relatively new area of research as well as in a wider commercial exploitation in Estonia. EGT geologists and geothermal energy experts Heikki Bauert and Rasmus Kont added this 3-day course series from the EGT. Rasmus Kont was very pleased with how the course was organized. The first day was packed with important and well-presented lectures about geothermal energy. For me, the most interesting topics were about prospective alternative uses for geothermal reservoirs and, of course, the geothermal potential of altered and fractured crystalline rocks, as we in Estonia are only starting to look deeper into our crystalline rocks when it concerns the potential harvesting of geothermal energy from deep sources, he added. Naturally, visiting the GTK Rock Lab on the second day of the course was an eye-opening experience. We had lots to learn on how, perhaps one day, equip our own prospective rock lab at EGT for geothermal energy research. The last day, of the course was reserved for the field trip to the coast to the Kop Arnas area. It was a sum up and consolidation of knowledge gained from the previous lectures and lab visits. When it comes to geology and exploitation of geothermal energy, then out on the field, you can see how much more complex everything is compared to textbook or lecture examples, narrated Heikki Bauert. He added, it is difficult to make assumptions and generalizations on natural processes based solely on the lab data. You must know and understand the big geological picture as it occurs in nature. Interestingly, the same crystalline rocks we looked at and studied in Finland are also present in Estonia. However, they are buried below the sedimentary cover, our national pride, the limestones, for example. Therefore, these lectures and field excursions in Finland were quite valuable to us at EGT. Both geologists agreed that EGT, as relatively new in geothermal energy research, could benefit from future cooperation with the GTK when it comes to starting the implementation of research and exploitation methods the Finnish have already been using for many years. Let me just show you one thing for the start. That's from Think Geoenergy, Geothermal Energy News. World's deepest geothermal well. Geothermal heating ambitions in Finland. Drilling rig on project site in Otaniemi, Finland. With the deepest geothermal well drilled. Finland is looking at utilizing geothermal energy for heating as efforts to cut carbon emissions and become climate neutral by 2035. The deepest geothermal well in the whole world. In other words, there isn't too much heat there in the ground if you have to drill many hundreds of meters. And I also have been talking about geothermal energy quite a lot. And somehow I came to the conclusion that geothermal energy or geothermal activity is part of volcanic activity. It is not something which is just there and interferes with volcanics, you know. Phreatomagmatic eruptions where we have much water included. It's not some random occurrence because we know that there is so much more water still within the crust and much more than is on the crust, hence the seas and the lakes and all these other things. So there's much water in the crust. But if we talk about geothermal energy, we also have to think about, or at least I think about the word thermal as an indicator of heat. So if something is not frozen, let's say there's water pouring out somewhere which is in a temperature of 1.5 degrees Celsius, it is very cold, but it is still in the range of thermal because it has a temperature and it is liquid. So it's just on the very low range of geothermal activity. And then we have those hot geysers like Yellowstone. There's like almost steam, or there is steam coming up. So it's very hot. It's on the other side of the range, of the thermal range. But let me show you just a few pictures from my own papers about geothermal energy and Finland and stuff like that. For example, in my mountain water paper, which came out or got published some weeks ago, I talk quite a lot about geothermal activities. And this is somehow one of the things which triggered me to think about the whole thing, like once again, about the Alps and their water. This article. Textbooks and geoscientists may be wrong about how the Alps were formed. But anyway, geothermal activity. We have to scroll down a bit. We have the Dragon Castle and the River Rhine. We have those pile dwellings. There are quite many of them around the Alps. There are also pile dwellings on the southern side of the Alps, which probably could come in handy today and in the following days, because there might be flooding going on. Geothermal baths. Roman legionnaires built the first large-scale thermal baths here in the 2nd century AD, which paved the way for the spa settlement of Aquae Helveticae. The baths at Aquae Helveticae made up the most prominent Roman spa settlement in the territory of present-day Switzerland and served as a place for medical treatments, as a religious center, and as an important social meeting place. And I assume that these hot wells have been there before the Romans, and they had probably quite similar functions, so to say. And not too far from the baths. It's like this map is too rough. I cannot draw it because they are so close. We have fulgurites or fulgamites. I never know which one is which one. So we have these aqua helveticae here, where we have the fulgurmites or fulgurites and Kaiserstuhl Vulcano. And they're all connected with the River Rhine. And of course, all the other rivers are connected to the Alps, from where the Rhine is originating from too. In my paper, I show this map because I think it's very interesting. This picture illustrates the geothermal potential of Central Europe. The hotspots in Germany and France are volcanoes. And there is another hotspot here. And there is a hotspot here. Some hotspots here. And if you... Sorry for that. And if you look at Turkey, there is a rather big hotspot there. Bursa, where we had some time ago the cloud, this very ominous cloud, is somewhere here. In other words, it's in a region with very high geothermal potential. So now the question is, of course, how is there any hot water down there or any heat in the first place, rising up from the depths? These are the sea urchin spines, or spikes, or spines. Hoop theory, like volcanoes. I have made videos about this kind of volcanic ash clouds being this kind of antennas for the volcano. And if you scroll down, still some more. Yeah, there's a bunch of stuff to read too. And some pictures, but I think it's the next one. No, it's just a breathing volcano maybe, which is besides some geothermal activity in the Alps. Schauberger, wide rivers, pH and voltage, so it wasn't the next. It's also not that one. This one. This is in a way how I think the heat is generated in the center of Earth, because there is a cosmological Berkeley current going through Earth. That's why we have Aurora Borealis and Aurora Australis. This is where it enters and goes out. And since the Berkeley current is counter-rotating, it rotates in both directions and many directions at the same time. There is energy going in and out simultaneously. So I think there might be a plasmoid at the center of Earth. It is in a way like a geoid, which is alive. And the parts where, for example, that's some lab plasma, where it makes a connection to the shell, so to say. Here's another one, here's a small one. Here it doesn't do any connection, or there isn't a connection yet. It might be that there is going to be a connection established at some point. And these are the points where we would expect volcanoes or geothermal activity. And this, of course, since it's a plasmoid, it's very hot, it generates the heat, keeps Earth alive. It keeps the magnetosphere alive, it keeps the clouds in place. It, like, well, for those who know about the Sapphire project, you probably somehow can envision of what I mean. This is somehow very much simplified. This is a Birkeland current where we can see what kind of elements accumulate basically and in what layers. And here we have the double layers. And one of these double layers might be the moho, which is some kind of a conductivity anomaly at some depth. The moho depth is something very interesting. And on the outer side or outer periphery of the Birkeland current, we have hydrogen and oxygen. And this might be the very reason why Earth is a blue planet. And we have also this very thin atmosphere here. And this is in a way also the plasmoid. The plasmoid is maybe something like a spherical Birkeland current, you know? So this is a Birkeland current turned 90 degrees in order to make it look like a sphere. But since I have no idea how to make overlays, it looks like this. But let's go back quickly still to Finland and Finland's geothermal activity after we learned that they are drilling at the really southern tip of Finland, the deepest geothermal well in the world. So it's really under stone, the heat here. But in my other paper, which is basically about Finland, Plate tectonic issues, the influence of electricity in rock forming processes, and a coherent connection between science, mythology, and history of Finland. There, I show several things related to geothermal activity. And I have no script for my videos. I plan them somewhat on the go. So maybe I have to search for something. Geothermal activity in Finland. Actually, it's here. The geothermal potential of Finland is very low, even at its most active points, which are at the southern tip of the country. When you go north, it gets less and less. As far as I know, there are no geysers or thermal springs in Finland. The region of Helsinki and Turku are basically the only ones with some potential. In Helsinki is a geothermal project going, where they are drilling the deepest hole in the world to get geothermal energy. Some sporadic local hotspots are found as far north as Lapland, and also in eastern Finland in the Koli region, which is not too far from here. Koli is one of the most popular tourist attractions in Finland. It is a small mountain range besides the fourth largest lake of the country, Pielinen. The highest or largest peak of the mountain range is called Ukko-Koli. The word Ukko is related in Finnish mythology to thunderstorms and lightning. The mountain range is an accumulation of giant fulgumites. It would only be logical if some deep penetrating electric discharge event not only sucked material from the ground upwards through magnetism, it also would alter the ground to some depth, ionize the ground, which through this process, the viscosity changed, things with different electric potentials moved around, and even some underground gas bubbles could have been formed, as where we have quartz veins. Some of the effects could have been influencing geological structures very deeply and make a temporary connection to deeper levels of the mantle where is water, and for some time there was coming warm water from deep below. After some time it might stop through crystallization deep below. Near Koli, in the same mountain range, is a cave called the Devil's Church. As we learned, that devil is basically Venus, the serpent of creation and destruction. And it had its fiery tail. The cave is 33 meters long, C-shaped boulder cave. So we have it again, a C shape, a C pinch. It is said that once upon a time there lived a mighty witch, Ukko Kinolainen. I have to say that I am from Central Europe, and all the stories I heard about witches, they were women. But in Finland, witches are most often men. For whatever reason, I don't know. So this witch is a man, but it's a witch. Anyway, it is said that the witch was so mighty, he could make the well boiling. This is a very important hint for geothermal activity being once present in the Goli area in ancient times, let alone a C-shaped boulder cave being a hint for an electrical discharge event. So that's a map from the GTK. GTK. Number 1, Goli area, where we had the witch, and obviously there is some red color. It might be not much, but it's red. The plasma rocks is also slightly elevated. Of course, that's a rather bad quality of the picture. Yeah, actually, I forgot. Here is it already made bigger. Yes, I surprised myself. Yeah, I did it. But anyway, the plasma rocks, I'm not exactly sure. Maybe they are still down here. Here we have some envisionment created by myself with a cell phone, like of electrical discharge event. We have craters of all sizes. If you don't recognize that, that's Finland. Here is Russia, Lake Ladoga. And I might be somewhere here. Rather close to those plasma rocks. We have craters in many sizes, many shapes and forms, as the interplay between electricity and the ground is making it too. We have also molten metal on top of rocks, which I think is also a very good indicator for electricity playing a huge role in the whole process of these rocks. So where we have these rocks, what we are looking at now, there is also a slightly enhanced geothermal activity hotspot. And still a little bit more proof about the electricity being a part of the creation. We have the surface conductivity anomaly over Scandinavia, and the plasma rocks are within the red area. And there is a copper mine. And there's a very big, Europe's third largest ancient copper mine, like some 40 years ago. It has been a very important copper mine for Europe. So there was a lot of copper. But anyway, let me show you still quickly some clouds. Yeah, this doesn't look like much. They were rather faint. First, I was intrigued by these here in the background because they had this kind of dent or something. But anyway, these, they were rather faint, and somehow they seemed to be much higher than the other clouds. It's hard to say. And I tried to enhance a little bit, and then I figured out that I have to enhance very much in order to make it visible for you what I have seen. Because there is structure to those. First I thought this might be some remnant of an airplane flying around. But there was just one flying around little bit funny in southern Finland. This was a little bit after I saw the clouds, but I don't think that this machine would have made it so quickly to the position where it's on this picture. And it turned out it's Bloom Geomatics from Norway. They are making pictures, very accurate pictures of the ground. But anyway, I haven't seen or heard any airplane. At least not this kind of. So I enhanced still a little bit more. Now it almost gets a little bit visible. What I found so intriguing, also that's something very odd. What's wrong with that one? Here, some kind of structure starts to appear. Yeah, I made several photos of this, and there is this green stuff, and the whole, like, there's just this ring. So where are the more enhanced pictures? Yeah, here's one. You see the structure of that? There's this kind of feathery thing going on here, and it seems to wrap around, and here we have this kind of perpendicular features. And here we have something like a knot. Lack of a better term. And here is probably the most enhanced version of that picture I can show you, but there is some kind of structure to that little round thing, and it moved just across the sky. They didn't move at all, those clouds. They just, in all those together, moved over the clouds until I just couldn't see them anymore. They didn't change at all, which was interesting. And then the sky turns cloudier. And that's the same picture, a little bit enhanced. It was very interesting to see that, because there seemed to be some kind of a convergence zone just above our head. And there's bird persons flying. Swans. Usually they are in pairs, but here we have three. I don't know, maybe it's an omen. Swans are very important to Finnish people. Yeah, and here they're still flying. Check out the sky. There were really sharp lines on that. And I try to take as much as possible into one picture, because I really appreciate it. That's, I think, a video maybe. Yeah. This just... I saw the end from where I was, but I didn't see the beginning. If there's an end or a beginning of that. Yeah, there might be. Here's somewhere it stops. And the whole thing was moving to that direction, but if you looked closely, the clouds were moving in this direction within that confined space of that convergence zone. I didn't really have time yet to check Windy, and my video's already much too long. Now let's maybe end with this one, make an enhancement quickly, in order to pull forward some details. Trying to, at least. Yeah, maybe something like that. Yeah, that was something interesting today. But anyway, thank you. Almost a half an hour. Oh, thanks. Bye.